to all of you. Once again, welcome to another beautiful session on NEET Bytes by Meritnation. So, I guess all of you are in good shape, good state of mind, and ready to solve some more questions, aren't you? So, welcome Gaurav. Hi Aman. Hey Meghna, welcome. Rehan, good evening. Sharoz, good evening. Aditya, no problem, welcome. Good evening, Aradhya. Hi Anjali. It's all right, boy. It's okay. Welcome to the class. How are you doing, everyone? It's so good to see you once again. And as you can see right in front of you, today we will be discussing another beautiful concept. Okay, so everything in biology is highly beautiful. Okay, so here we'll have more conceptual questions. I'll be telling you a bit about them. We will discuss what are the different theories, what are the different factors you have to consider when you talk about transport in plants. Right? Okay, exactly. So in today's session as well, we will have a quiz. Okay, we will have the quiz going on for like same pattern for 1 minute that will be allotted to you. You will be answering in that minute. Okay, and after that, I'll explain the question. At the end of the session, we'll have names of the top rankers. So another welcome to Babita and Balu, Varun, Nikki, Paris. Welcome. Okay. Now, guys, understand one thing. When we talk about transport in plant, there are pipelines that you have to consider, right? Okay. And what are the pipelines that you discuss? So that is something you discuss in plant anatomy. And you talk about xylem, right? You talk about phloem. So their structure we've discussed already in the anatomy section, right? Okay. In today's class, today's topic, basically, if you read this topic, it's more about what are the factors that are determining the transports process in plants. Okay. What are the different type of pressures you have to read in here, right? What are the different theories you have to consider? All these things you need to look upon while studying the transport in plants. Okay, so that's all right, Yash, no problem. Transport in plants, this chapter is from class 11th NCRT. Okay, and you will get a time to revisit your concepts. That's all right. Okay, so let's get started, everyone. Let's move to the very first question of the session. Okay, are you people ready for that? Are you guys ready for that? Can I have a big yes coming out from you? And remember, you'll have a minute to answer. Okay, everybody must be like ready in that minute. Cool. So there comes the very first question. Time started. Okay, now this question is about poverty. Yep. Okay, it's about poverty. And poverty happens to be the diffusion pressure deficit. In the given question, it is showing you different values of turgor pressure, osmotic pressure, and DPD. Okay, so I am giving you a hint. You've got to look into the DPD. Remember this thing every time when you solve such kind of questions and DPD is there, you need to look into the DPD. And what is DPD? It's something related to poverty, right? I'll explain that. Okay, so you have to look into the DPD. They are giving you that cell A has DPD of 3 atm and cell B has DPD of 5 atm. What will be the direction of water movement? How the direction will be determined here? Will it be moving from cell A to cell B, from B to A? There will be no net movement of water. There will be equilibrium between the water. What is the right answer? Think about it. Your time is about to get over. And there it is. The time is up. And I can see many people getting confused in this question. Guys, understand the correct answer is option A. How does that happen? See, DPD is determined by the amount of solute dissolved. Okay, the amount of solute present in a cell. If you look into the cell A condition, you are finding that it is 3 atm. In cell B, it happens to be 5 atm. Now, if you look, you will realize that this guy, cell A person, it is having less solute. That is the reason that water is more in here. Okay, and if you look into B, B is having more solute. B is having more solute. And hence I can correctly deduce that it is having more water. Understand? That is why we are referring that from cell A, water will move to cell B. Here, there is more water. Let me write down. In cell A condition, you are having more water. In cell B condition, you are having less water. So if you look otherwise into water, now it is moving simply from more water to less water. This is just like you are having two perspective into looking something. Okay, like you have a glass, it is half filled, half empty, right? Yeah, I mean all that theory of somebody being realistic or something like that. Okay, so water will be moving from A to B because A cell is having more quantity of water. It is having less DPD. It is less poor, and cell B is more poor. Okay, so that is why it is going high to low only, Nikki. Water is moving from high to low only. But in here, you are not provided with the water potential. Remember, water potential is not given in the question. Understand this thing. And for that matter, in such type of questions, always look out for DPD value. Always look out for this. Okay, but DPD determines how much quantity of solute and how much quantity of solvent will be present in a particular cell, right? So if DPD is less, it means more water. DPD is more, it means less water. Just keep it down somewhere and learn it. Okay, so first option happens to be the correct answer happens to be the option A. Okay, so this is, I guess, clearer to you guys. Okay, I understand it takes time. It takes some time in, getting to this concept. Okay, but remember, learn it something the way I have written. Right. Now, moving on to the next question, everyone. We now jump on to the next question. Here comes the next question. Okay, your time has started. Okay. And the question says that the rupture and fractionation do not usually occur in the water columns, which are there in vessels and tracheids, during the ascent of sap. Why? I mean, how does it happen that in a plant, in a tall, big tree, water keeps on moving up, water keeps on moving up? And the plant is going mad. It is dancing with the wind, right? It can do, I mean, somebody is hopping on the plant, even then it is dancing, but water is like, yo, I will move, I will keep on moving. How does that happen? Who is that guy responsible? How does water column not break? It maintains the integrity. Is it because of transpiration pull? Is it because of lignified thick walls? Is it because of cohesion and adhesion? I don't know what is that. Or is it because of weak gravitational pull? Right? How does that happen? So your time is about to get over. Birth out the right answer, everyone. And the time is up. So a big congratulations to all those who have given C as the answer. Wow, what does that mean? What is cohesion and what is adhesion? Understand this thing. Cohesion and adhesion, both of them are attractive properties. Okay, these are the properties of attraction, like, but between who and whom? So cohesion happens between water and water molecule. Okay, and I tell you, it's a big attraction. I mean, if you see water flowing, okay, coming out from your tap, you take a pair of scissors and try to break it. Can you do that? No, it's nonsensical. You cannot break, you cannot cut the water column. You can't do that because it's a big attraction between water and water molecules. Same thing apply in plants as well. What about the next one? Adhesion is the attraction which is shown by water with the walls of either vessels if they are moving in vessels, or it can be with the tracheids as well. So water loves the walls also, water loves water also. And when you have so much of unity in the name of love, I tell you, nobody can break the column, right? So that is why water column doesn't break. It keeps on moving, keeps on moving, keeps on moving. Okay, so that is the right answer. Transpiration pull is somebody which is pulling the water up. Okay, it is a factor which is pulling the water up. But how does water gets pulled up? This is another factor. How does water listens to transpiration pull? It's because of cohesion and adhesion. Okay, this is the concept you need to look in here. All right, guys. So I understand. I believe that this is clear to you. You've understood both the properties. And this is actually known as cohesion and addition theory. It was given by Dickson and Joly. These are the two people, okay? They provided this to us along with the transpiration theory as well, okay? Right. Now, let's go on to the next question. The time starts. Question is asking you very simple thing as to how does root pressure develop in plants. So roots are under tremendous pressure because they have to appear in NEET examination, right? Okay, they have to appear in NEET examination, they're under pressure. But the option is not showing you about that. Option doesn't mention about NEET or something. Option says it's because of increase in transpiration. It's because of active absorption. It's because of low osmotic potential in soil, or it's because of passive absorption. Let me give you a hint over here, guys. Root pressure has got nothing to do with transpiration pull. Okay, it has got nothing to do with transpiration pull. Keep that in mind. I mean, if somebody is forcing you to do something, then it depends on you whether you want to take the pressure or not. If you do not want to take the pressure, you will not listen to the person. Say, hey, I don't want to listen to you. So it's a big hint that I just want to give, right? Exactly, Aradhya. So the time is up, everyone. Let's get into the right answer. So I know many of you will be disheartened after knowing the answer, but take it easy. Take it easy. The correct option is active absorption. Basically, root pressure develops when roots are participating, okay? When roots are directly involved, they are directly involved in water absorption. What does that mean? Understand, guys. When transpiration pull is pulling the water, when transpiration force is pulling the water, at that time, roots are doing it passively, okay? Roots are doing passive absorption under transpiration pull. Keep this in mind, okay? Roots are doing passive absorption under transpiration pull. But when there is no transpiration pull, that is during the night time, during the evening time, at that time, roots will be involved in active absorption. And that is when the root pressure develops. Exactly. Okay. So do not think that transpiration pull is somebody who can make anything to go happen in this world. No. Sometimes it is depending on the will of roots as well, right? Exactly. So keep this in mind. Under transpiration pull, roots are like, okay, we will do it. But when there is no transpiration pull, roots are becoming, we are responsible. We are responsible now. So they will do active absorption. Okay. So this is, I guess, clear to you, right? Now, quickly, we will jump on to the next question. Here comes your next question. Time starts. Question is asking you that in soil, there are lots of different types of water present, right? What is the only type of water that is available for root absorption? I mean, root cannot access to every type of water present. That's not physically possible for them. And this is one very easy question. So is it gravitational water the roots are pulling in? Is it capillary water? Is it hygroscopic water? Is it combined water? So you still have some time. Birth out the right answer. I know you guys know this question, right? This is one very easy concept. Okay, wait for till we come up exactly. Your time is about to get over. Think, and write. Okay, the time is up, everyone. And correct answer is capillary water. You've done it well. Exactly, Aradhya. So capillary water is something which is present between soil particles. Okay, it is present between soil particles, right? And it can be absorbed by the root hair. Only root hair are having the access to the capillary water. Okay, that is the reason. This is the right answer. And Aditya, epiphytic roots, are they inside the soil? Think about it. Are epiphytic roots in the soil? Because if they are in the soil, they will have access to capillary water, right? So if they are not in the soil, then I think that will be different, isn't it? So that is why this answer goes for capillary water. And capillary water always moves against gravity, right? So keep this in mind as well. Easy question, isn't it? And I know that all of you are a little satisfied right now that finally you got some question which you know. Okay, now combined water is something which is present with the minerals. You write it like, suppose you write the formula of some mineral, put dot, and then you write H2O. That is something which is not freely available. So that's not say, oh, I'm available, take me with you. That cannot happen. So water actually shows, the sign of hired. I am hired already. You cannot hire me anymore. That's a combined water. Okay, water is already busy. Now, moving on to the next question. Time starts. Water movement between cells is due to. Now, what is that force or what is that pressure which is allowing the movement of water between two cells? Okay. Now understand, guys. Let me give you a very, mundane concept. Something goes from a place to another place based on the concentration and the need, right? So here again, you have to think about poverty of cell. Okay. If a cell will be poor, it will be getting it from a richer cell or a less poor cell. Okay. So that's how you have to think in here. A very, very, so basically, less poor cell will give water to more poor cell. And they are poor in terms of water. Okay, they're poor in terms of water. Think like that. And so your time is about to get over. I can see people putting up answers. And yes, you're right. It is DPD. Diffusion pressure deficit. Deficit is lack. And what is lacking here? Diffusion pressure is lacking, right? And who builds the diffusion pressure? Water molecules. Here, water molecules are building the pressure. If there are less water molecules, it will be more deficit. Yes, exactly. So poor in sense of water. If a cell is poor, I'm saying it simply means that diffusion pressure here is more than this guy. Okay, this guy is having less diffusion pressure. Diffusion, I'm writing power. Let it be power also, no problem. Diffusion power is less in here. So of course, water will move from here to here. Okay, WP is water potential. Okay, WP is water potential, which is just determined by water thing. But when you count DPD, here you are considering both. You are considering solvent as well, that is your water, and you are considering solute as well. That is why it is a whole package. It's a wholesome package, right? So I guess this is clear to you. This concept is getting somewhere near to your brain. Try to absorb it. Try to imbibe the water. Okay, or not water, the concept. Next question, everyone. So your time starts now, and it says that with the increase in turgidity of a cell surrounded by water, the wall pressure will. If water is becoming more of turgid, then wall pressure will increase, it will decrease, it will fluctuate, it will remain unchanged. What's going to happen, right? Kavya, incipient plasmolysis is when plasmolysis has just started to occur. Okay, cell membrane has started to retract, but you can't see the perfect retraction. That's incipient, about to happen. Okay, so bring up the right answers, everyone, and let me see how many people give me the right thing this time. And I can see that. I can see many of you trying to assert with the some option. Okay. And your time is up. Your time is up. And to all the people who have given option A as the answer, big congratulations. You're right. Because if turgor pressure increases, the wall pressure increases. Can you tell me one thing? Who is providing turgor pressure? What is the person? Can you tell me the name of the person giving turgor pressure? That is your tonoplast. Okay, that is your tonoplast, the wall of the vacuole. And the wall pressure is built by, the cell wall, right? So when tonoplast is putting pressure on the cell wall says, I am not a mad person. I will not take the pressure. I will put pressure back. So one is inserting from inside, the other one is inserting from outside. There is a whole fight going on. And you know what happens in this fighting? Cell enjoys. Cell says, wow, if they both are fighting, I will not burst. Let them fight. This is my gain. Okay, that is why the option is increase in here. Okay, very good, very fine. Let's move on to the next question then. Okay, balance will be there, exactly. Balance will be there. Moving on to the next question. So here comes the next question. Another beautiful question. Okay, I love this one, right? Okay. The water potential and osmotic potential of pure water. You see this guy? Okay, you have to talk in terms of pure water. Okay, turgor pressure will be by tonoplast. Exactly, Aradhya? Yes. Okay. So will water potential be zero and osmotic potential be zero for pure water? Oh, pure water seems to be quite an poor person, isn't it? Then 100 and 100, the maximum. Okay. 0 and 100 respectively, 100 and 0 respectively. What do you guys think in here? Okay. Understand one thing. You have to talk in water potential, you have to talk in terms of water molecules. In osmotic potential, you have to talk in terms of solute molecules. Okay, and this is a little bit difficult. No, not difficult. I would say a different concept, but that's all right. There is nothing that you cannot understand. Okay, so your time is up, and yes, correct answer is A. Both are zero. How on earth is that possible, man? Yes, it is. Let's talk about osmotic pressure. Okay, if we talk about osmotic potential, it is also known as solute potential, and it is determined by the number of solute present. And you know that in pure water, there will be no solute. In pure water, there will be no solute. Hence, it is zero. Right. Okay. What about water potential? Water potential is considered to be maximum. It is considered to be maximum for pure water. Why? Because pure water is having only water molecules, only water molecules, and the maximum value for water potential is zero. Okay, and any solution will have less than zero, and less than zero becomes negative. So for pure water it is maximum, and because this is biology, maximum is considered as zero. Do not apply your mathematical brains here. I mean, jokes apart, but right, that's true. So option A is correct. Okay, now let's switch on to the next question. Right, guys? I hope this is clear to you. Let's move on to the next question. Okay, and your time starts now. The time starts now. The question says that water potential of an actively absorbing cell. Now, if it is actively absorbing cell, it means that this cell is in need of water. It is in need of water. Okay, it is having less water molecules. It is having less water molecules. So if water molecules are less, it means water potential is less than zero. Water potential is less than zero. And just now I told you, I just now told you. So let me see how many of you understood basically the question. These are really fun questions, right? Really fun questions. So I'm just waiting for the time to go up and everyone put up the right answer. Right. Okay. Will it be always positive, always negative? It's highly negative person. Don't go around it. It's zero. It's more than one. Okay. The time is up, guys. And to all the people who have come up with B option, you're correct. That's cool. Okay. Understand that whenever water potential is less than zero, it becomes negative. And if it becomes negative, it means that the cell is in need of water. Cell doesn't have water, cell will need water. And when cell is in need of water, it simply means that it is absorbing the water. It is going to absorb the water. So absorbing water will always have a negative value for water potential. Water potential is always also depicted in this way. So it will have a negative value for water potential, right? It just won't anyhow water to come and fill inside it. Okay. Easy concept, I guess. You've understood how to calculate them. Okay. Then, without much delay, we'll look into the next question. Okay. Right. Non-absorbing cell. I'll just tell you that. Okay. Now, people, this is a assertion and reason question. It's not something a part of your NEET preparation, but still I got this because we want to practice concepts. And here you get a concept. Okay, so let's read the assertion. Assertion says that water and mineral uptake by root hairs from the soil occurs through apoplast until it reaches endodermis. What do you think this assertion is right? I mean, endodermis is a negative character. Okay, endodermis is a negative character. It doesn't allow water to move apoplastically. It does something. Okay, reasons is suggesting that endodermis is negative in character could be because there are Casparian strips present and Casparian strips are suberized. Can you relate both the assertion and reason? Okay, do you think that assertion is highly substantiated by reason over here? Is it a right thing going on? Okay, so I'm giving you like 10 seconds extra for this particular question. Okay, and I can see people putting up some question. They're putting up some answer. Very good. So time is up now, guys. And yes, you've gotten it correct. Okay, so here assertion and reason both are correct. And not only they are correct, reason is very well mentioning the assertion. It is defining the assertion. So A is the right answer. Well, guys, you know that we are using the term apoplast for the dead component. When water is moving through cell wall, the dead component. And symplast is something we are using when water is moving through the live component, isn't it? The cytoplasm, the plasmodesmatal connection, right? And Casparian strips are strict gatekeepers. They do not allow cell wall to pass the water. So when water will reach the Casparian strip of endodermis, water will be directed towards cytoplasm. Water will be directed to move through the plasmodesmata. Okay. So this was the last question of your session. Okay. And another one. No, this was not the last question. I'm sorry for that. There's another question, another assertion and reason. Let's just try to solve this one as well. And now this is my fun. This is something I really love, this particular concept. It's about imbibition. Okay. And imbibition is my favorite topic from this portion. Okay. Assertion says that when the dried seeds of pea are placed in a tin of water, okay, and in a tin and you are adding water up to their level, and then the lid is put tightly. After an hour, you will find that lid will be blown off. Do you think it is possible? I mean, pea plants are having some nuclear energy in them. Pea plants are having nuclear energy, and when you try to cover them, they become rebellion. Okay, I don't want to be covered, and they will blow off the lid. Is that right? Think. And reason says that it is because of rapid cell division in pea cells. So when you are trying to cage the pea cells, when you are trying to put the pea cells within the lid, they will undergo cell division. Will that happen? So if it is right, if it is wrong, think, take your time and come up with the right answers. Okay. If you do not, I will give you explanation as to why this is right. I'll be giving you 10 more seconds to solve this particular question. Okay. I can see some people writing some option. Okay. Right. The time is up, guys. And correct answer is assertion is true, but reason is false. Now, pea plants are not having nuclear energy, for God's sake. Pea plants are doing imbibition. Right. And imbibition is something which is not letting pea plants within the lid. They say, no, we are going to absorb the water and will blow off the lid. Okay. We are going to blow off the lid. Right. So that's not because of nuclear energy. That's because of imbibition. Okay, so that's not resulting in cell division. It is resulting in cell elongation. Okay, it's resulting in cell elongation. So reason is wrong. Reason mentions cell division. That's not good. That's not right. It's cell elongation. The cells which are like that, they'll become like that. And when they become like that, they blow off the lid. Imagine, okay, imagine a cell going like that. Okay. So not a plasmolysis, Nikki, that is intake, that's imbibition. Okay. Lid blows off because then your pea seeds are going to assert pressure on the lid. Okay, the pressure is so immense and so intense that lid will not be able to fight it back, and the lid will blow off. Exactly. That is something that will happen over here. Right. So with this, we have finished our session. Okay. And I will be just announcing the names of people who have come up with the first, second, and third rank. Okay. Right. As P will absorb water, hence volume decreases solely. No, why the volume will decrease? Why the volume will decrease? Only the water volume will decrease, no, Radhya. But think about the volume of pea seeds. So lid is getting blown off not because of water, but because of pea seeds. They are the people there. They are the actors over there. Now you can see right in front of you, there is an announcement that Meritnation is launching NEET Catalyst program. Okay, we'll be having test series over here. Everything is mentioned. You can read it and try to become a part of it. Okay, now this is the time to announce the top rankers. Are you guys ready? You must be. Okay, so hold on. Here comes. First rank is occupied by Aditya. Well done, boy. You've gained 7 marks out of 10. Second rank is occupied by Ishan, Meghna, Paras, Shagun, and Shahroz. You people have gained 6 out of 10. Well done. That's quite impressive. And third rank is occupied by Aditi, Aman, another Aman, Avreet, Minakshi, and Spurti. Spurti, I like your name. So that's you have gotten 5 marks out of 10. That's impressive performance, guys. Keep it up. Okay, and I understand that this particular chapter is more conceptual. Okay, there are things that you have to keep in mind, and you have to look from the another side of the coin. I totally understand that. So don't take it if you have failed in many of the questions. Do not worry. Just read back the concepts and you'll gain it. Okay, so with that, I take your leave now. Thanks for coming to the session. Thanks for being participative. I wish you all the very best for your upcoming sessions. And I wish you a very happy learning. Stay healthy. Enjoy your time. We'll meet once again. Till then, it's me signing off. Bye bye. Take care.